Hello, YouTubers. Welcome to another Code Time with Blessed. And today we will be looking at something really unique. I think I'll be putting on a blue hat today and we'll be doing some form of digital forensics. I thought it would be cool to showcase the Redline tool as one of the tools that I use whenever I'm on an engagement that involves digital forensics, specifically to Windows, Linux, or Mac environments. So what I'm going to do today is I'm going to create a memory dump of this Windows 10 assumed to have been compromised on my network. Obviously, I actually played out this simulation to mimic kind of like a malware on this system and something happening. So I will use Redline to dump memory and go export it out for analysis, where we'll be doing some detailed analysis following a methodical approach to see how we can probably carry out digital forensics on a compromised Windows box or any other box on an environment on our network. All right, so let's skip the chat and get on the party. All right, so at first I'm going to pretty much install Redline on this Windows box. Then I'll collect the dump I want to collect. Then we will just start that analysis once I'm done installing and collecting. Yeah, at this point I must stress that this is only going to be effective if the evidence has not been corrupted. Obviously, whenever there's a breach like this, if you have a first responder who is not experienced, you find out that they may mess up the evidence, and at such point it becomes difficult to actually collect enough artifact to analyze and study the techniques and procedure of the threat actors which you'll be going after specific to that environment. Okay, so you want to be sure that the first responder is actually someone who is trained enough to not corrupt or mess up with the evidence or evidences that were available to collect. So we've got Redline installed, and this is what it looks like. For this particular recording, we'll just create a standard collector. Well, we will go a bit deep. If you want me to, you can leave a comment in the video. I'll be glad to probably showcase deep dive into using this tool to doing some awesome 100 to 300 level deep into Windows dump. Okay, so let's create a standard collector for today. Then we'll just work with that at the basic level. So our target will be a Windows, which is this Windows server, this Windows 10 system here. And we could acquire memory image if we want to. If I click this option, we'll acquire an image of the memory that can be used for accurately acquire. But that's one of the best thing you want to do. But for this recording, I'm not going to do that anyways. I'm just going to set the target location for the export. Then we'll go ahead with this. I'm going to put it on my I think I'll put it on my desktop. Then I'll create a folder for this. I'm just going to call it a bit slow here, so call it okay, that should be fine. Then we'll just select this folder to dump our output in. Then we can click OK. Then we'll create the collector. Then we'll go execute the collector. Okay, so it's just giving us a bit of read up here to go. Your collector package is created and saved in the location. We're pretty much fine with that. Now I will look for that folder which I have created forensics. I should have the collector in here. So I want to run this batch script with admin privilege, so I can actually collect some good stuff. So this may take a while to run, and then complete. We'll wait for this, and after it's done, I'll come back to import and start doing the analysis with us together. All right, see you soon. So in our case, it seems like it's done collecting. We'll go into the sessions here. We'll see the analysis session 1 created. Then this is the analysis session 1.mans file. Now we can just double click on this. It will open up in Redline. Then we can start looking at what we have here. All right, so this may be pretty cool stuff to do, but we'll see how the result turns out to be from our perspective here. Okay, so whilst this seems like barely basic stuff, we can create another collector to do some more detailed advanced stuff. So I'm going to quickly run through this. We can see already handles, we can see memory section. Let's start doing some deep analysis, which we'll be looking at later on. We can see strings, we can search for that. It's got the function to search, currently there's nothing there. Ports, we can see ports and services and all that cool stuff around this box. But for now, we're going to close this one. then we'll just delete this session and create another session with a more detailed setup to be able to allow us to do what we want to do. So right in this folder, I'm just going to remove everything. Then I'm going to start this again with you guys. So I'm going to go again, creating a standard collector. Then this time around, we're doing this. Now we can edit our scripts. If you see that little click there. So this is where the dynamism comes in. So what do I want to collect? I want to collect as much as available for me for analysis. So I'm going to collect driver enumeration, collect strings. MD5 is pretty much fine for me. I don't need a SHA. Then maybe acquire an image of the memory. I think I'm just going to click on this. Then for disk, file enumeration, I'm going to collect as much as possible to enhance my analysis. Now, the more you click, the larger the file size. So I have to warn you there. Don't end up clicking everything. You have a very robust file size you may not be able to export. So I'm going to do disk enumeration and also volume enumeration. Then on the systems, I'm going to analyze restore points, registry hive, user accounts, and also prefetch according to what they call that. Okay, registry enumeration as well as event logs should be inclusive. Network ports DNS, so we can find out how the attacker is probably exfiltrating data. Browser, we will collect cookies from history, file uploads, downloads URL, thumbnails, maybe not necessary, index page not necessary. Then others, so others I'll collect services, the MD5, basically verify signatures, maybe. I'll collect the SHA one as well. Then task, I'm collect MD5. I could go verify whatever I'm seeing there against what virus total will have. Then I can be sure if it's some funny stuff or not. So common persistence mechanism, actual entropy, enumeration import, MD5, get resource. I'm just selecting a bunch of this stuff so I can enrich my results. Okay, great, we're good to go. Now, this may take a while. Again, we'll select that folder which we had created on the desktop forensics to save the collector in, then we'll generate the collector. All right, so we will go in that folder. We can run the bat file again. Now, this will take a while actually as compared to the first one. So just me trying to show you how in depth you can go, or you can remain at the basic level. Okay, we'll wait for this to finish, then we'll import and start our analysis. Okay, so data collection is finished, and as you can see in here, we've got the sessions. If I open the session, analysis session 1, which is what was created, we will see this analysis session 1.mans file. So we can open this file, then we will start the analysis. Okay, so if I double click on this, it's going to open it up in Redline. Then we can begin our analysis to see what was collected, then maybe do a bit of investigation to see maybe what the attackers probably had done on this box for us to be able to catch the bad guys. Okay, we'll wait for this to import, then we will just get back to this. Okay, so here in Redline we have our results. We can see we can start our investigation by following any of this path, but we're just going to do quick analysis to see what we can probably point out from these results. So first thing first, we can probably see the system information here. Gives us an idea. This is a background Windows server. It switched places with the Windows 10. We can see the processor info. It's Core i7. We can see multiprocessor free and just a bit more details. It's actually a VirtualBox. I'm using a VM on my host, so this is actually my host's details. And then we can as well see the system directory, which is a system32, system32. We can also see the domain name. It belongs to a domain, and the logged on user as well, who also belongs to that domain. Now we can start drilling into looking at processes. For processes, we can probably view handles. It's a little bit slow, so a bit laggy over there. We're just going to be patient with this. It's quite a heavy file, you know, so it's not something that just runs that smooth. Now we can analyze every bit of these processes. Let's say we want to find a malicious process, which we believe is a backdoor placed by the hacker, probably to maybe maintain persistence or whatever that may be. Now we could map this against a good or a good metric, like a baseline that we have in our environments to check the way this is actually behaving compared to the baseline which you have now. This is an investigation, so at some point you have to go really deep understanding what is happening. Now this is a bit slow, so I may be forced to just ignore some of these things. We can see all the handlers, you can see all the files handles. We can also look at each of these in details. I'm just going to skip that. We can view ports. Yeah, it's a bit slow. Okay, great. Now we can see the process names, the process IDs, or the parent process ID. Then we can see the primary path. And now this is where you as a responder, your analysis begins, because you need to start understanding these paths clearly defined, or they're pointing to something else that is malicious. Then I also want to look out for all these ports. Am I sure these ports are allowed to be communicating on these hosts, and also the remote IPs that they seem to be communicating to? Am I sure that's what has been allowed in the environment or based on the baseline? Or I can find a funny IP. We can take that up and go generate an IOC report. Basically, we'll be looking at that if time permits me. Now, also strings, we can see strings. I hate the fact that this is slow. Okay. Yeah, it takes time to load. The memory sections, probably the file system. Great. This is the file system from the roots, which is the C drive. We can go drill into each of these to find out what is happening. Is there any funny? Probably there are funny stuffs which we might find out. Kind of like we could find maybe users or probably any other thing that is not supposed to be there. Maybe we just look around a bit. I can see there's Glassfish and a pub. There's this forensics folder which I created. There's an AD share folder over there. There are users in here. We can see these are valid users. I'm okay with these users. I'm not seeing any funny, kind of like funny user over there because I'm using this box for testing actually. And as well as we can see the WAMP server, study it, the SSH server, we can look at that as well. Go deep, layers deep, understanding what is happening. This is a forensics investigation, so obviously that's where you put on your cap to start looking into each bit of the critical areas where you know you usually find the bad guys. Probably find out what is happening there. I'm looking quickly into the printers. I can see okay, these are valid. I could go all the way to persistence and see if there had been uh, anything of notes. Okay, probably there are some registry key modifications. Obviously, there may be something malicious which had actually happened, but obviously I won't be able to go into details for all of that now. So these are your registry keys that can be set for persistence. We can critically analyze each of them just by double clicking on it. It loads it up. Then you can probably study. It takes a while to load. Okay, you can analyze this, understand if it still matches with the baseline or it deviates from the baseline. Then you can also grab the hashes, go check if it's been modified. You can tell from that. We can as well go into, I'm just going to go a bit fast, in users. In users, I can see all the usernames. Look out for funny usernames. This computer is a domain controller, so you can see a bunch of accounts. Now this is why I start checking if there is an account that has been created, either a user or computer account that I know that it's not on my list. Remember, we had done a video showcasing how to audit Active Directory to verify what is happening. This you can tie to that maybe baseline and see what is happening, if there's anything funny from a user perspective who's been created and you have not actually done that, or it's not been defined as a user been created. Again, event logs is another place you want to look out for. In event logs, you can find, I'm trying to keep this video pretty short, so I may go a bit more faster. In event logs, you can find some useful stuff, very useful stuff. We can search or we can query based on a specific log ID, which we know maybe I'll make a video on the Windows event log just to show you some of those log ID. We can look at them and see how we can use that to probably just oppose what kind of event we're looking at, or maybe if it's failed login over and over and over, and we can probably type that down, or maybe like a warning here. We can go into this analysis. I'm seeing NT authority as person who is actually doing that stuff. I want to go look into that stuff. Okay, the user is NT authority logon. The NCDS. Okay, that's the event ID. I was speaking about that. Okay, this is for the directory service. I'm just going to go back. This is quite a heavy file, so it's a bit slow. Don't mind that stuff. Okay, we want to also look up for other kind of like error messages. That could be a warning, a sign, a tail sign. I'm seeing anti-authority systems and a bunch of these errors. It could be a tail sign that someone is trying to do some privilege escalation or something, and that's not working out or failing. Again, I'm not doing the detailed analysis here. I'm just showing you how this stuff works. If you want to know more, you can always reach out to me. I'll be glad to stage a one-on-one session if it's worth my time, anyways. Okay, great. So again, we can drill deep, specifically searching. We can search for attributes like maybe 34, maybe 26. Specific. I can go search for each of those event ID that I know I want to look out for. This is basically around information, but I can see this is anti-authority doing some stuff. I can as well search for other specific event ID that I want to go after, and maybe that will help me. I can see audits sources here. Okay, I'm going to skip that. I'm going to go into the task. Again, attackers usually use the task scheduler to actually schedule funny tasks for persistence. So you also want to go look into this task scheduler if there's any funny task that has been created that you think it's a backdoor, kind of like a theme. Let's see if we can find any. I'm not sure I'll be patient enough to kill my time looking for something important here. But if you would want to, I'll be glad to walk you through how that stuff works. Hive uploads, collaboration loader, IP address conflict. Something like this is of importance to go look into. Okay, great. Maybe someone is messing around in your network. All right. Again, we'll find if there's anything important. Okay, these tasks are triggered based on time. Update WP, nothing there. Let's look at action. Now let me see what comes under action, if there's anything there important. Okay, here I can probably, I've seen some PowerShell thing here. Exec, critical. Okay, we can drill into that to go look at what is happening there. If it's something we want to pay attention to and do some more research on. We can see the type is exec, executable part is CMD. So someone is using CMD to spawn PowerShell and pass that over to, oh, okay, update IP.ps1. Okay, this was my job anyways. I was playing with that. That's me. Okay, just to show you how fine-grained you can start seeing layers deep into activities happening on the box and do your analysis. I may need to put on my glasses here. Okay, over here ports, we can see ports. Let's save myself some time. I'm just going to move on. DNS, under this we can see a ton of them. I've actually seen this before. We can look at the local IP and the remote IP and do a bit of matching, see if those are actually valid in our environment. Okay, great. Also the path, we want to be sure we can see, we are sure of what is running the Elasticsearch. Okay, this is me actually doing stuff over there as well. I'm going to go to DNS. Under DNS, we want to probably start looking under the host file, see if there's a modification. I can see, let me look at that. What is happening there? OSCP digicert. Okay. Pointer, this points to, that's pretty much okay. There's no problem in that. You just go step back. Example air records. Okay, I cannot find any funny mapping happening here, so I'm pretty much fine with this. I can see we've seen the pointer record, the C name, canonical name, and the A record as well. Here over disk, you want to start looking at partitions as well. Okay, I'm going to have to stop this video here. It's going to be on 20 minutes. Okay, but anyways, this is just me trying to show you how you can take this. Now there are a bunch of things you could look out for. You could check maybe DLL services. You could check for maybe users that were created on rapid on the fly. You could check for processes. You could check for file names that are tagged to malicious file names. Check all the exes or executables running. You could even grab hashes and go validate them for known executables. You could collect the hashes and go test them against maybe VirusTotal to see if there's a modification that's been done, as well as you could find probably bit low levels, looking at maybe tasks that have been scheduled, critically analyzing them, maybe for persistence mechanism, and also persistent privilege escalation mechanisms as well. Okay, this will be all for the recording today. Thank you for your time. I hope you love this content. If you do, please like and subscribe, and I'll be seeing you in the next recording. Have a good day. Thanks, and bye-bye.